This is Adel Gasly. I'm going to present to you part 1 of the chapter about three-phase induction, or what is called also asynchronous machines. Asynchronous or induction machines are part of AC rotating electrical machines family. Induction machines can be single or multi-phase machines. However, this chapter will cover only three-phase machines, and single-phase machines or multiple-phase, more than 3 phases, will be covered in special or advanced machines course. In 1882, Nikola Tesla discovered the rotating magnetic field, which is a fundamental principle in physics and one of the greatest discoveries of all times. So Tesla discovered the AC induction motor that is considered one of the top 10 greatest discoveries of all times. Nowadays, about 65% of the electric energy in the industrialized countries is consumed by electric motors. In the industrial sector alone, about 75% is consumed by motors, and over 90% of them are induction machines. Induction machines are very popular because they are rugged, reliable, easy to maintain, relatively inexpensive, and their power to density or output power to weight ratios are higher than some other motors. Small single-phase induction motors are used in many household appliances, such as blenders and juice makers, vacuum cleaner, washing machines, refrigerators, air conditioners, hair dryers, fans, etc. Large three-phase induction motors are used in traction and propulsion vehicles such as trains, planes, cars, motorcycles, ships, submarines. They are also used in lifts and hoists such as elevators, escalators, and cranes. They are also used in pumps, compressors, and mills. As you can notice, induction motors have a lot of industrial applications, which make them the prime mover of the industry. While induction generators are of one rotor type and have externally excited rotors, they are also called self-excited or doubly fed induction generators. Externally excited generators are widely used for regenerative braking of hoists driven by three-phase induction motors, and self-excited generators are used in the windmills. As I mentioned earlier, in this course, we'll concentrate mainly on the three-phase induction motors. A typical three-phase induction machine construction is illustrated by this figure. This is the stator and this is the rotor. We will see later that there are two different types of rotors. This one is what is called the squirrel cage type of rotor. The rotor is fixed on the drive shaft that is mounted on the yoke or frame of the motor through bearings. The stator has a winding placed inside the slots of a laminated core. The terminals of the stator windings are connected to the terminal box, and to help the machine cool faster, a cooling fan is usually mounted on the same drive shaft. This fan brings fresh air inside the machine in order to take out heat produced by machine's losses, such as copper and core losses. Every electrical machine has a nameplate that indicates its type and rated parameters and characteristics, such as the number of phases, the rated power, rated voltage, frequency and current, the rated speed, efficiency, and also other parameters. The content of the nameplate are usually defined by standards like this one, which is defined by the International Electrotechnical Commission IEC standard. There are mainly two types of three-phase induction machines, which are classified based on their rotor structure. We find the square cage rotor type and the wound rotor type. To understand better the difference between these two types of machines, let us look first at the schematic of their winding construction. This is a schematic representation of a three-phase induction machine showing its stator and rotor windings. This is a schematic diagram of a square cage rotor type induction machine. Notice that the rotor winding is a closed circuit that is not accessible from outside, while the stator winding is energized from an external three-phase power supply. This is a schematic diagram of a wound rotor type induction machine. Notice that the stator is the same like the previous type, but the rotor is different. Indeed, in this case, the rotor winding is accessible through slip rings and brushes system. The rotor winding can be connected to an external circuit, which could be, for instance, a variable resistance. More details about the construction of each part of the machine will be discussed in next slides. Let us start by looking at the construction of the stator. The stator core is made of laminated sheets with teeth and slots structure to accommodate the coils of the stator winding. A three-phase winding made of several coils that are placed in slots, which are cut on the inner surface of the stationary part. Fiberglass insulation sheets are inserted in the slots before inserting the coils in order to protect them or their insulations from being scratched and mechanically damaged, and also to increase their electrical protection by increasing the insulation between the hot wires and the stator core and frame. After all coils are placed inside their respective slots, wedges are inserted to tighten the coils inside the slots. Then coil ends are arranged properly inside the stator so that they will not touch the rotor structure, which will be rotating at very high speed. Note that the distance between the rotating rotor structure and the stator core and winding is usually very small. Therefore, very strict and fine arrangement of the stator winding coils should be made and carefully inspected. The ends of the stator coil are connected together to form the stator winding, which can be connected in star or delta to form a three-phase connection. These winding terminals will be inserted inside the terminal box to allow the stator winding to be fed from a three-phase AC supply. The stator windings are submerged inside polyester-based varnish to make them more resistant to moisture and increase their electric insulation. Finally, the stator is heated inside an oven for several hours so that the varnish will harden, making the stator winding mechanically more rigid. Now let us move to the rotor and discuss its construction. As mentioned earlier, the rotor could be either square cage type or wound type. We will start with the square cage type, which is brushless. The square cage winding consists of bars embedded in the rotor slots and are shortened at both ends by end rings. Note that the rotor core and bar assembly has a twist. The bars are slanted or skewed for two reasons. The first reason is to make the motor run quietly by reducing magnetic hum and to decrease slot harmonics. The second reason is to help reduce the locking tendency of the rotor. Indeed, the rotor teeth tend to remain locked under the stator teeth due to direct magnetic attraction between the two. This happens when the number of stator teeth is equal to the number of rotor teeth. Bearings are placed at each end of the rotor in order to mount the rotor in its housing, with one end of the shaft extending to allow the attachment of the load. In some motors, there is also an extension at the non-driving end for speed sensors or other electronic controls. The generated torque on the rotor forces motion through the rotor to the load. Ventilated holes are made inside the magnetic core to allow better cooling of the rotor. The squirrel cage rotor is the most common type because it is more rigid, more economical, and simpler to construct. Now let us see the slip ring or wound rotor type. The wound rotor windings have the same form as the stator windings. Coils are also inserted into the slots of a laminated rotor core. They are also isolated and fixed with fiberglass sheets and wedges, and then varnished and treated in an oven. These windings are usually connected in star. The terminals of the rotor windings are connected to 3 slip rings, and using stationary brushes pressing against the slip rings, the rotor terminals can be connected to an external circuit. Now, I invite you to watch this movie on YouTube, which explains very well the elements and construction process of induction machines. You can find also its link in the description below. This is the end of this part. Thank you for watching this video.